Okay, then we will start now this session. This question is visible, right? It was asked in gate. It was asked in gate 2008. Can you try? It is based on mass balance. Hello. Have you read this question? Okay, means can you tell me the process? How will we solve this question? Yes, yes. Hmm. Okay. See, okay. Yes, yes. Like 6 tons of concentrates are given and 100 tons of total. A flotation plant treats 100 tons of chalcopyrite. So tailing amount will be like 94 ton. So from that we can calculate copper content in tailing and copper content in concentrate. So can you try? Hello. In 1 ton 1000 kg. There is no need to convert in kg. You can directly calculate in ton also. It is asking percentage, so there is no need. Anybody else? Likhit, Gaurav? Yeah, yes, yes, yes. Okay, okay. Yes, sir. Means after calculation, you are getting option B, right? The percentage copper in the tailing is right. Okay. So let me solve this one also. See, in 100 ton of chalcopyrite, it is given 2% copper. So, and from here we can directly calculate copper content in 100 ton. So, copper content will be 2 ton. And this in this chalcopyrite 100 ton, the concentrate amount is 6 ton. So, tailing amount will be 94 ton. And it is given that the concentrate has 25% copper. So here copper content in concentrate will calculate 6 into 25 by 100. So we'll get 1.5 ton copper. So total copper content was 2 ton. So in tailing, copper content will be 2 ton total, 2 ton minus 1.5 ton copper. So it will be 0.5 ton copper content in tailing. So it is asking the percentage of copper in the tailing. So we know copper content 0.5 ton copper divided by total tailing content is 94 ton, and it is asking percentage. So if you calculate, you will get 0.53%. This is our right answer. Option D is right answer. Okay, anyone have any problem in this question? You may ask or write down in chat box. Okay, so should I move to next question? This is also based on mass balance. So you read this question and you try yourself first and tell me the approach. How will we solve? How will we solve? Yes, yes. Are you solving? Sanjeet. Okay, okay, try. 0.02% the final sulfur content. Are you asking, telling about in weight percent, right? Yes, yes. This is right answer. Please wait. Let us see other people's opinion also. Gaurav, Prasanna, and Abhishek. Can you tell how? Okay, okay. Partition coefficient means here sulfur content, weight percent of sulfur you can say in slag, and weight percent of sulfur in metal. Here it is still, so sulfur content in slag divided by sulfur content in steel in this case. is called partition coefficient, and the value is given here 30. So if you calculate sulfur content in slag at equilibrium and sulfur content in metal, in this case it is steel, in equilibrium, and if you divide it and you make it equal to 30, then you can get the value of sulfur in slag, and from there you can get sulfur in steel, because suppose uh, early in slag there is no sulfur content, and after when it is mixed, then sulfur content suppose it is x. So early here it is 0.8 kg, for example. In steel, sulfur content is 0.8 kg, and after when it is mixed with slag, it becomes 0.8 minus x, now sulfur content. So if you you take a weight percent of sulfur in slag divided by percent of sulfur in steel, and if you make it 30 and if you calculate x value, then from here you can calculate sulfur content in slag, and after that it is asking final sulfur content in steel. So just you subtract by 0.8, so you will get weight percent of sulfur in steel. Are you getting? Like it is given 1 ton, so from here we can calculate how much amount of sulfur is present. It is given 0.08% weight percent, suppose, so it will be 0.8 kg. So if you put here, it will be x by 100. Suppose we are calculating in weight percent, into 100 divided by 0.8 minus x. This is in kg, so we are making it in weight percent. 0.1 ton of slag, so it is 100 kg. It is equal to 30. 0.6 kg. This will be sulfur content in slag. So finally in steel, sulfur content will be 0.8 minus 0.6, which will be 0.2 kg. So here we have to calculate in weight percent. So 0.2 kg in 1000 kg steel. So in 100 ton, 100 kg steel, it will be 0.02 kg sulfur. So weight percent of sulfur will be 0.02 weight percent. It was asked in 2008. Gaurav, Kamesh, if you guys are facing any issue, please ask. Okay. So should we move to next question? Prasanna, is there any issue in this question? Oh, you may try this question. It is based on Stokes law, and it was also asked in GATE 2012 or 14, based on this same concept. Have you read this question? Can you tell me approach how to will solve? Yes. 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 Okay, miss, here you are said right, but there is one mistake. Like we will multiply like uh, diameter square into time equal to constant. We will get finally. If you will solve that equation, you will get diameter square into time, that will be equal to constant term. And from that we will compare both equation and we will get time finally. Yes. So after what will be the answer? We have here four options. Can you solve? Yes, yes. Anybody else? Yes, it will be 30 minutes. C. Okay, okay. Deoxidation of liquid steel with ferrosilicon produces spherical silica particles. The particles of 5 micrometer diameter takes 3000 minutes to float up through a 2-meter height of liquid steel. The particles of diameter is given 5 micrometer and it takes 3000 minutes, and height is given 2 meter. For particles of 50 micrometer diameter to float up through the same height, the time required in minutes is, we have to calculate time, height is same and diameter when it is 50 micrometer. Suppose this is our steel ball and this is liquid bar. Here there will be force Fb, viscous force, and buoyant force Fb, and this will be gravitational force. So if we combine Fb plus Fb to Fg, Fb will be equal to 6 pi meter Rv plus Fb, it will be like m fluid into G, and Fg, this is mass of steel ball into G. So we can write 3 pi meter if we want to write in diameter, and here we know rho equal to m by v. So if you calculate it, finally you will get 1 by 6 pi dq, and this is for liquid. So I am writing rho L G equal to pi by 6 dq rho m. This is for this steel ball G. So finally, if we want to calculate it, you will get V value d square rho m minus rho L G by 18. This is meter viscosity. So it is given, we know V equal to height by time. So we can write height by time, and here it is given d square. So d square equal to, we can write oh wait, d square by V equal to 18 meter rho m minus rho L by G. So are you getting till now here? This value is constant for this condition. So, and we know V equal to height by time. So you can write into T equal to some constant into H. So this will also be constant because your height is same. It is 2 meter. Suppose this is 2 meter. In both condition, it is given 2 meter. So d square into T will be constant. So can you calculate now time? Diameter is given 5 micrometer in first case, and in second case it is 50 micrometer, and in first case it takes 3000 minutes. So in second case, how much time will it take? 30 minutes. Okay, now anyone facing any issue? Is it okay? Anyone facing any issue? Who asked this question? Should I move to next question? It was asked in GATE 2014 or in 12 also. So you may check out that. It has also been asked many multiple times. This question. How will we solve? Yes. K root. Yes. 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 What is that equation called? Yes. Hmm. Please solve. Yes. Gaurav. Gaurav and Abhishek. How will we solve? Are you guys here? Gaurav, Abhishek. Uh, A metal with an average grain size of 36 micrometer has a yield strength of 250 megapascal. So 350 megapascal. And where we have to calculate when d value is 4 micrometer. Here we have to find out friction stress. So we know Hall patch equation sigma y equal to sigma I, sigma I we can say or sigma naught plus k into d to the power of minus 1 by 2. where this is lattice frictional stress. This is locking parameter. So it is given 250 megapascal. When illustrate this is constant value for this condition, and K value is also not given. Diameter is given 36 micrometer. So 250 sigma 0 plus K by 6 equation 1. In second case, you can write down 500 equal to sigma 0 plus K by root 4. So it will be K by. So if we subtract equation 2 minus 1, we will get K value. What would be the K value? Sanjeev, what was the K value? 750. What was the unit? MP. But also here you take care of diameter is also given. So it will be some meter also. Not mm. Like it will be megapascal per micrometer. In this condition, this will be. Hmm. Okay. So if we subtract, you take care of unit because it is very important in GATE. Because if you miss, you will miss like 5 to 10 marks you may miss. Units are more important than your solution. So if we subtract, we will get 250 K by 2 minus K by 6. So here K by 3, K will be equal to 750 megapascal per micrometer, square root of micrometer. So we can put in an equation. Sigma 0 will be equal to 500 minus K by 500 minus K value is given 125 megapascal. So option C will be the correct option. See, this is in megapascal, right? And this is also in megapascal. And this K is megapascal per micrometer, square root of micrometer. And this is diameter it will. So if you take ratio square root of micrometer, so it will be cancelled out. We will get micrometer. Sorry, megapascal. So final answer will be 125 megapascal. Is there any issue? Oh, you check this question. What are you saying? Option A. Okay. Anybody else? Hmm. Why dot product should be equal to 0? Yes, 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 yes. Hmm. Cos, yeah, cos 90 will be equal to 0, right? Anybody else? Suppose this plane is HK, and if this is our closest pipe direction, sorry, UVW, then normal of this plane will be like this one, and if this direction will lie on this plane, then the angle between these two will be 90 degree. So if we take a cos product of this HU plus KB plus WM, will get 0. So based on that, if we calculate for what, for option A, dot product will be 0. Here bar 1 1 bar 1, this is the plane, bar 1 0 1. So if we take a dot product for condition for first direction, it will be minus 1 into minus 1 plus 1 into 0 plus minus 1 into 1. So this will be 1, this will be minus 1, so 0, and this is already 0, so it will be 0. Second case we will calculate 0 1 1, so we will get minus 1 into 0 plus 1 into 1 plus minus 1 into 1. So this is 1, this is minus 1, and this is 0, so it will be 0. Similarly, for third direction 1 1 0, for this plane, if we take a dot product, it will be minus 1 into 1 plus 1 into 1 plus minus 1 into 0. So this is 0, this is 1, this is minus 1. So this will be 0. So, and if you calculate here, let us see, check for this one also. For option B, minus 1 plus 0 minus 1. So it is coming minus 2. So this will be not the correct option. This does not lie on this plane. And if we check option C, for first case, it is minus 1 plus 0 plus 1. So it is okay. For second case, minus 1 plus 1 minus 1 plus 0. Third case, 0 plus 0 minus 1 plus 1 equal to 0. This is also. Where am I making mistake? Okay, this is plus 1. Okay, plus 1. So yes, yes. Plus 1 plus 0 plus 1. In this case, it will be also, it does not lie on this plane. And if you check option D, for first case, it is minus 1, 0, minus 1 minus 1. So it will be minus 2. So our option A will be the correct option. Is it okay? Anybody is who is facing issue? You may write down in chat box also if there is any problem. Voice from your side. I have solved this question earlier. Can you try? How will we solve? Ye- Yes, yes. What are you saying? Sorry, what was the question? You are saying some equation. You are telling some equation. M by 100. This one. Okay. Okay. And this both are same, but this is we calculate it at 100 x magnification for per inch square. And can you tell me what is capital N? Yes. Average number of grains per square inch at 100 x magnification. That's why you have divided by here 100 in this case. And what is small n? Yes. And here it is magnification. So can you solve? Why it? Yes, 9 will be the answer. Oh, see here esteemed grain size number of a material is shown 64 grains per square inch at a magnification of 200x. It is given 64 grains magnification 200x. M is magnification here 100. square, it will be equal to 2 power of n minus 1. So this will be 2, and 2 power 6 plus 2, it will be 2 8 to n minus 1. So n minus 1 will be 8, so n will be 9. Is it okay? And from here you can also calculate, like at 200x magnification there are 64 grains. So at 1x magnification it will be like 64 into 200 square. So at 1x magnification, because formula is based on for 1x 100x magnification, so 64 into 200 divided by 100 whole square, and it will be equal to 2 power of n minus 1. So if we solve this, we will get 2 power of 2 to the power of 8 or to 2 power of n minus 1. So n equal to 9. Is it okay? Anybody facing any issue? So we are moving to next question. The two samples P and Q are given of a brittle material, have crack lengths in a ratio of 4:1. The ratio of fracture strengths of P and Q measured normal to the cracks will be. What do you say? The option B will be correct. Means how will it be solved, Sanjeev? Hmm. Yes. Yes. For P case, suppose it is crack length is AP, and for Q case it is AK. So it is asking the ratio of fraction strength of P and Q. This is how half crack length. So it is in ratio, so that it will not affect our answer. AQ value is 1 by 4. So it will be 1 by 2. The answer will be 1 is 2. Is it okay? And we know one equation also from fracture toughness. KIC is equal to sigma square root of pi. From here you can also see this stress is inversely proportional to 1 by square root of it. So, but it is brittle material is given, so use this Griffith equation. The structure sensitive properties are, here we have four options, which are the structure sensitive properties. Q and S you say. Abhishek Kumar, why A will be, like it is asking structure sensitive. Elastic modulus. It is structure sensitive or insensitive? Yes, yes. It depends on only atoms and at some extent some temperature if there is some variation. So elastic modulus are, it is structure insensitive property. Density is structure insensitive property. Elastic modulus, temperature, melting point, it is structure insensitive property. This is melting point. So P and R, it is structure insensitive. Option B will be the correct option. See, yield strength, it depends on many external factors. If like if there is a crack length present, then your yield strength will decrease. It depends on crack length. For example, if A is smaller, then we will get more yield strength. Yes, yes. Whether it is longitudinal or transverse direction. Anyone facing any issue in this previous question, you may ask. We have 5 minutes. You may ask. If there is no question, then we will meet next Monday.